Here's something that sounds like science fiction, but it's actually happening right now. There are underground data centers operating across the globe, built entirely from chips that were stolen from shipping containers and manufacturing facilities. They're assembled in warehouses, powered by bootleg electronics, and they're competing with legitimate cloud providers for AI workloads. This week, Nvidia's CEO Jensen Huang declared the whole operation a dead end. But here's what makes this story so startling. These illegal operations exist because the demand for computing power is so desperate that an actual black market emerged. Companies and researchers are so hungry for AI processing capacity that criminals saw opportunity. They source components from dozens of countries, forge documentation, cross international borders with equipment hidden in shipping crates, and build entire data centers in places where oversight is minimal. Think of it like someone building an airline from salvaged plane parts, then expecting it to compete with established carriers. The real truth Huang is pointing at is that a black market data center is fundamentally broken. The chips aren't genuine, they overheat under load, they fail without warning, and there's nobody to support you when things go wrong. And that's where the story gets interesting. Because this whole operation is about to collapse not because of law enforcement, but because the technology simply doesn't work. To understand why anyone would try this, you have to grasp how intense the competition for computing power has become. When advanced language models hit the market, think GPT-4, DeepSeek, Claude, every major tech company on Earth suddenly needed thousands of graphics processors and AI accelerators. Nvidia controls roughly 80 to 90% of the high-end AI chip market, and they're selling every single unit they manufacture. Single H100 GPU costs between $20,000 and $40,000. A data center needs hundreds or thousands of them. Do the math, that's tens of millions of dollars for a single facility. For a startup or research lab without massive capital, it's literally impossible. So some players started looking at gray market channels. They discovered chips could be sourced from liquidated inventory, from countries with lighter regulations, from international resellers, and yes, from shipments that went mysteriously missing. The appeal was obvious. You could build a data center for maybe 40 or 50% of the official price if you skipped the warranty and ignored some paperwork. It's like buying a stolen car and hoping the engine doesn't fail before you break even. Desperation is a powerful motivator, and for years it seemed like it might actually work. Then some of these operations scaled up. They weren't just dodgy startups anymore. They were processing real workloads, making real revenue. Here's how the black market infrastructure actually works. First, someone has to source the components. They buy directly from gray market suppliers in China, Vietnam, or other countries with lighter regulations. Some chips are overstocked from legitimate manufacturers. Others are pulled from liquidated inventory. Some are literally counterfeit, manufactured to look authentic, but made with cheaper materials. Then comes the forging, creating paperwork that makes these components look like legitimate stock. Customs documents, certificates of authenticity, all fabricated. The equipment gets shipped across borders, often divided into smaller shipments to avoid detection. Once it arrives at a warehouse somewhere with minimal oversight, maybe Eastern Europe, maybe Southeast Asia, maybe somewhere in between, they're assembled into servers and racks. These aren't manufacturers with climate-controlled cleanrooms. They are warehouses. The cooling is inadequate. The power distribution is questionable. The entire facility is built on the assumption that nobody's going to inspect it. Then they're rented out as compute capacity. A startup pays pennies on the dollar for GPU time. The operation profits from the markup. The problem? These systems fail constantly. Chips that overheat can't sustain workloads. Counterfeit components give wildly inconsistent performance. There's no warranty, no support line, no recourse. You rent the hardware, it crashes mid-job, your data's gone, and you've got nobody to call. To be concrete about this, there have been busts and exposés of these operations. Security researchers have found entire data center facilities operating in countries with lax enforcement, running on nothing but stolen and smuggled components. In some cases, tracing back the supply chain shows chips that were literally diverted from Nvidia shipments en route to legitimate customers. The scale is bigger than most people realize. we're not talking about a handful of small labs. We're talking about hundreds of millions of dollars flowing through these gray channels. Some of these operations have thousands of GPUs running simultaneously, processing AI workloads for paying customers. They advertise on underground forums as unregulated compute or offshore GPU rental. The pitch is always the same: massive discounts, no questions asked, instant deployment. What's remarkable is that some of these facilities have actually been visible to satellites. You can see the massive data center buildings on Google Earth. They just look like any other warehouse, but the electrical consumption patterns don't match what a legitimate operation would need. Law enforcement agencies in multiple countries have been investigating these operations, but they move fast. As soon as one facility gets raided, the equipment gets relocated to another country. The business model is inherently mobile because it's inherently illegal and it's inherently unsustainable. But here's what most coverage gets wrong: the operators know the clock is ticking. Now let's talk about what separates a legitimate operation from a black market one. When you buy computing power from AWS, Google Cloud, or Microsoft Azure, you're getting components that came through official channels with full traceability. Every chip in the data center has documentation. Every server has been tested. There's redundancy built in. If something fails, there's a replacement on the shelf. Support is available 24/7 when something goes wrong. You've got a team of engineers ready to fix it. You're also getting legal protection. If there's a security breach, the company is liable. If your data is lost, there's a service-level agreement that guarantees compensation. With a black market data center, you get none of that. You rent compute capacity, it crashes, and your recourse is a voice on an encrypted app who might ignore you completely. There's no contract. There's no warranty. There's no service-level agreement. If your AI training job fails halfway through, you've lost the compute cost and your time. If there's a security breach, you have no legal standing. Your data could be copied, sold, or exposed, and the facility operators would never be held accountable. That's the fundamental difference. Legitimacy isn't just about price. It's about reliability, security, and accountability. You pay more for official channels because you're actually getting something worth paying for. What Huang's statement really signals is that this entire model is breaking down. From Nvidia's perspective, black market data centers represent stolen revenue. They also represent massive liability. If a training job fails on stolen hardware and someone loses millions in compute investment, that failure gets traced back to using counterfeit chips. It could create legal exposure for both Nvidia and the companies running the black market operations. But there's a larger implication here for the entire AI supply chain. The shortage of compute power is real, but it's also temporary. Nvidia is ramping up manufacturing. AMD is releasing competing chips. Intel is getting back in the game. Over the next 12 to 18 months, the price of GPU access will come down as supply increases. The black market was riding a wave of desperation, but that wave is crashing. Once legitimate sources are abundant and affordable, there's no reason to take the risk of using stolen components. Companies that built their operations on black market infrastructure will either upgrade to legitimate systems or get shut down. More importantly, this sends a signal to the entire industry. Supply chain integrity matters. The regulatory scrutiny is going to increase. Customs enforcement is going to get tighter. The authorities now understand that chip smuggling isn't a victimless crime. It's funding criminal enterprises and undermining national tech sovereignty. Let's talk about how a legitimate supply chain actually works and why it matters so much. When Nvidia manufactures an H100 GPU, it goes through multiple quality control stages. Every chip is tested under extreme conditions to verify it meets specifications. Then it's packaged with documentation that includes the date of manufacture, test results, and a unique serial number. This doesn't prevent theft. It makes theft traceable. When a shipment moves from a factory to a distributor to a reseller to a data center, every step is documented. That means if a chip appears somewhere it shouldn't be, the chain is broken. A legitimate data center operator can look at their equipment and verify its provenance. They know exactly where it came from. If someone tries to claim a chip is genuine, but the serial number doesn't match Nvidia's records, it's a red flag. The supply chain also includes insurance, warranty coverage, and legal accountability at every step. If something goes wrong, if there's a defect or a security vulnerability, there's a clear path to resolution. This costs money. It makes the whole process more expensive, but that expense buys reliability, security, and peace of mind. When you run critical AI workloads on legitimate hardware, you're not gambling. You're operating a sustainable business. That's the contrast Huang is drawing. The black market looks cheaper upfront, but it's actually the most expensive decision a company could make. So here's what this moment really means. Jensen Huang's statement that black market data centers are a dead end isn't just commentary. It's a prediction that's almost certainly going to come true. The math is simple. As legitimate compute power becomes abundant and affordable, there's no competitive advantage to buying stolen and smuggled chips. The only thing you gain is legal risk and operational fragility. For companies currently running on black market infrastructure, the window to transition to legitimate systems is closing. The regulatory pressure is increasing. Customs enforcement is tightening. The financial risk is only going up. For the rest of the industry, the lesson is clear. Supply chain integrity isn't optional. It's foundational. When you're running critical AI workloads, whether that's training a model or serving inference to millions of users, you need hardware you can trust. You need support when things break. You need legal recourse if something goes catastrophically wrong. The black market promised cheap compute, and for a moment it seemed like it might work. But Huang is right. It is a dead end. The future belongs to legitimate channels, transparent supply chains, and accountable operations. Stay skeptical of compute offers that seem too good to be true, because they probably are. If you want to follow the latest developments in AI supply chains, semiconductors, and the enforcement actions happening right now, follow for daily AI news.